Hey everybody, today we're going to be learning number systems. And there's a whole a lot of different number systems, and we're going to go over a few. And it's important because later in future videos we're going to be talking about set notation and how to write out domain and range using number systems. So let me just give you a little bit of history. The first one starts with 1, 2, 3, 4, and it goes on to infinity. The next set of numbers we want to look at is the invention of one number, and that is 0. Yeah, I know what you're thinking. It's kind of strange, but I would say, as far as the timeline of the history of the world, 0 is actually a new invention. I mean, it's still very old. So we add 0. And we can go off into infinity, okay? All right, so what we want to call that number system is a whole number. And we represent that with a W, okay? So no big deal. The first set just has 1 through infinity, and they're called natural numbers. And then we added 0 to infinity, and we call them whole numbers. All right, the next number set we're going to be looking at is called integers. And the only thing about an integer that's different is we are adding. See, notice we're adding. We started out with 1 through infinity, then we added 0. So now we're going to add something else. We're going to add negative numbers. And this goes on into infinity. And then we got 1, 2, and then that goes all to infinity. Now, the way we write these symbols, this is very important you know these symbols, natural, whole, and integer. Now, some people write it with an I. But most of the time, or where I come from and what I see the most when we use it for range and domain is called Z with a Z. And see, that comes from some German word Zollen, and all it does is mean integer, okay? So you would see Z. All right, so far we have looked at only whole numbers, okay? So natural, wholes, and Z do not have fractions or decimals, okay? So keep that in mind. So the next number system set we need to look at is called, we're going to be talking about rational numbers. Now there's rational and irrational, so let's go through this now, okay? So 2/5 is a fraction. It's also called a rational number, okay? Now 2.7 is a rational number because we can turn that into 2/7. So it's a rational number. 0.31596 is a rational number because we can turn that into a fraction if we wanted to. Whole lot of numbers, okay. So those are rational numbers, okay? Also, let's look at 0.59 repeater. Now, have we talked about repeaters yet? All that means is that it goes on and on, 59, forever, okay? And so instead of continuing to repeat that, we put a line over both numbers, and that lets us know that they repeat. Those are also rational numbers. So, and we could also turn that into a fraction as well. Now, I don't want to get into how you do that, but it would be 59/99. All right. So how do you write a rational number? Well, a rational number would be depicted as Q. Now earlier you saw me draw a 0. I probably shouldn't have done that. That is not something we need to get used to. So I will go back and continue to write my zeros like that. But yeah, that is a rational number, a cube. All right, so quotient. Q means quotient. Quotient means a division problem, okay? You would take, how would you find the decimal of that? You would take the denominator, divide it into the numerator. So what the heck is irrational? Well, we got to have a counter argument to the rational, and that is the irrational. That is all the other stuff. Now remember, we started with natural numbers from 1 to infinity. And then we added 0, and we called it whole numbers, 0 to infinity. And then we added negative numbers, and we called that Z. Okay? And then we added the rational numbers, which are fractions and decimals that can be repeating or repeaters, okay, repeating decimals. The irrationals are all the other stuff, the stuff that just don't make sense. Okay? So let's take a look at this for a minute. If I said the square root of 5, if you entered that into your calculator, you would get 2 point blah 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 blah. And so you would look at those numbers. I'm just going to make up. And you would say, do I see any patterns? Any kind of repeaters? Okay? Does one number repeat over and over? Does two numbers repeat over and over? Do three numbers? If there's no pattern, then it don't make sense. It's an irrational number. Okay? All right, let's take a look at this one now. So when you've got the square root of 25. Okay? So we know that's equals 5. And that is a rational number because it's 5. I mean, so what about the square root of 5? Let's go back to that again. Now we said that was irrational because it was a bunch of decimals and it didn't make sense. Well, how about this? We know that the square root of 4 is 2. Okay? And then the next square root after 5, probably 9, is the square root of 3. Okay? So if this is 2 and this is 3, all the square roots 5, 6, 7, 8 are irrational. They don't turn into whole numbers, okay? Or repeating decimals. So it's all the other stuff. Just the stuff that just has no pattern, that just means nothing. Okay, and I don't want to say it means nothing. We'll use it, but we'll label it, and we label it as, well, that's the sign of rational. And then if you put a line over the top that says not, that deems it not, so not rational, and that's what are irrational numbers. All right. So we have one more. And remember, we're going to be using this as set notation and domain and ranges and some other things in future videos. Now, we talked about natural numbers, 1 to infinity. We talked about whole numbers with the addition of 0. We talked about integers where we added negative numbers, negative to infinity to positive to infinity. We looked at rational numbers. They're the decimals and the fractions that have an end or they repeat. And then we have irrationals. That's all the other stuff that we can't find a pattern to it, okay? So let's finish up this video by talking about one more number system, and that is all real numbers. And that is everything that we talked about in this video. I'm not going to add anything else. How would you write that? Sometimes you see it like that, and then sometimes you just see it like that. Okay? All real numbers, natural, whole, integers, rational, irrational, everything. All right, so I'll look forward to seeing you in the next video. Check you next time.